Okay, so welcome back to the Cloud Native Compass. I'm your host, David Flanagan, and today I am joined by Natan from Wix Engineering as we discuss and share wonderful insights into the world of event-driven architectures. Hello, Natan. How are you today?
Hi, David. A pleasure to be here.
Well, thank you so much for joining me. I'm really excited for this episode. Event-driven architectures are just what keep me excited about technology, even after 20 years, and being able to dig into it with experts and understand how they approach complex domains via event-driven architectures is always the highlight of my week. So thank you so much for joining me. I discovered you via the Wix Engineering blog, which turned out to be a bit of a goldmine for engineering content. So before we dive into that and event-driven architectures, could you share a little bit more about you?
Sure. So I've been a software engineer now for close to 20 years, I think. And it's been such a lovely experience for me. So for the last 8 years, I've been in Wix, which really drove me to become much better engineer in all of the skill sets that engineer should have, and also be able to share it and want to share what I've learned and what Wix has achieved with the rest of the world. And I think it's really important, and I encourage every engineer, no matter what is their skill level, to do the same and try to write a blog post about their experiences and what they learned. There's no such thing as something that is not interesting or something that no one will care about. And even if you don't get a lot of exposure, it's still great to create content. It gets you in a creative high. So I really recommend it.
Yeah, that's great advice so early on in the episode. Like, I often refer to this as like a collective knowledge when I speak at conferences and such. Is like the more we can get engineers working on their own issues, right, that their organization has, that their team has, that they personally have, and the more we share this knowledge in a public forum, the more that other people can learn and build upon that knowledge, right? It provides foundations for people to go and do wonderful things with technology. So that's such great advice. So thank you for sharing that. So you've been at Wix and you're saying that it's kind of, improved your engineering chops, you're working on fun problems. I mean, just to give people some context and clarity on what Wix does and what kind of scale they're operating at, can you just share a bit more details there?
Sure. So Wix has a very powerful website building platform, and over the years, it has enabled all kinds of people with different skill levels to build websites. We were pioneers in building websites based on AI, for instance, even before it became so trendy and viral like these days. And in more recent years, we expanded our reach from like self-creators to agencies and web professionals, and created a whole ecosystem platform. So you don't only manage online presence, but also manage businesses online, from stuff like building and managing your bookings and schedule for your yoga and Pilates studio to sophisticated tools like third-party dropshipping. And as we expanded our offerings, more and more customers were brought in, and the scale has really increased. So we have around 2,500 microservices in production, even more and added every week. And they come up with a lot of visitors, around 1 billion unique visitors every month, which gives more than 500 billion HTTP requests per day and 70 billion Kafka events produced every day. So very a large scale and a very big distributed system where there are a lot of challenges to keep up the high availability, performance, low latency, and resiliency and fault tolerance.
Wow. I mean, I was asking to give the audience clarity on scale, and I think you've just surpassed the numbers I even had in my head. So those are some pretty chunky numbers you've got running through your system. So let's kind of touch on something there, right? You said you've got 2,500 microservices, it's growing every week. Did Wix start off as a monolithic application, or has it always been a microservice architecture or service-oriented architecture to some degree? And were you part of that migration? If so,
Yeah, I think very early on, Wix adopted the service-oriented architecture. I think there were monoliths. Like at the very beginning, I think there were services that were expanded into a monolith and were written like, I think back in like 2006, 2007, 2008. It's before my time, but with like Java technologies, like enterprise technologies, monolithic stuff. But very, very quickly after that, especially since we adopted Scala, we went over to look more smaller and smaller services and microservices, and haven't looked back since. Really, we kept on improving standardization, ease of building a new service with all the different cross-cutting concerns that are involved, because it's really a big challenge. So like keeping velocity fast with all the needed building blocks for every service, because while we may not be monolithic, it's in some respect you can think about the Wix platform as a distributed monolith, right? Because you have all these verticals that offer a lot of more extra features for the different kinds of websites. So you can have an e-commerce store, but you can also have the bookings features, or a restaurant or a hotel, etc. And all of these have to work together along with the site editing infrastructure, etc. So you have a lot of different services working on very different domains, but at the end of the day, they need to have basic language to communicate, to propagate user context, and to do regulation like GDPR and a lot of other concerns. Of course, concerns where you work with microservices, it's much harder to debug, much harder to know what's going on. So you want to have good monitoring infrastructure in place and an ease of like a lot of tools to investigate. So all of that has to be built into each and every microservice. And that's why I say, okay, they are created independently by different teams and they have completely different domains, business domains. But in the technical aspect, you can think about them as a distributed monolith.
All right, awesome, thank you. Like, if those, you're an engineer, right? Your 9 to 5 is to write code and help build out the Wix platform. How many of those services do you have in your head out of the 2,500? I know it's a completely superficial question, but I'm just curious, like, what is your exposure to application that size? How much of it can you actually grok on your own?
Right. So as an infrastructure developer, I'm exposed to potentially all of them. Like each day, some team from another part of Wix will contact us about some question or issue. So at times I'm familiar more with parts, different parts. But of course, it's really impossible to keep all 2,500 in your head. So I know the different verticals. I know the different challenges. Like some verticals have more throughput than others. As the funnel shrinks, you get less like technical challenges. You can still have a lot of API and business and like business logic challenges, but you'll have less technical challenges. So I'm probably more familiar with the higher scale ones, I would say. But getting 2,500 is impossible for sure.
Yeah, I mean, I don't know what the split is between application services and infrastructure services, but I imagine there's a lot of identity stuff going on. There's a lot of caching going on. There's the message processing. There's consumers. Like, when you have, and I'm making some assumptions right now, right? Because I don't know a lot about Wix yet, but I imagine there's a substantial amount of platforming that has to be done to support the developers to be able to, onboard and run their services when you get to this level of scale. So, in fact, before I say like what are the challenges, let's just start off with like, why go down this path of event-driven architectures for a system like Wix? Like, what are the pros and what are the cons of this?
Sure. So usually when you start off with microservices, if you come from monoliths, then you're used to function calls, right? And procedure calls. And then the natural extension of that when you split it up to multiple services is to do remote procedure calls or something similar like REST APIs. And that's a very natural thing to do. Now, what I've noticed that can happen in such situations is it can be a bit restrictive. For instance, you want to call a service, and actually what like in e-commerce your cart service calls the catalog service and the inventory service, etc. And what usually happens is like a big chain of calls that occur in such situations, right? Like you mentioned, identity probably will be in the context, but also a lot of business procedures happen on different services, and you start getting a very, very large chain of requests between these services, and this can really form a big challenge where you need to take care of making sure that you still have resiliency and fault tolerance in place. And that can be tricky because you have to make sure that you meet deadlines and give out responses back in an orderly amount of time, like a normal amount of time. And when you spread out the requests and get like a Russian doll of requests here, you end up being really dependent on the availability and the performance on each and every one of these services along the chain. So it can really make your requests brittle. So of course there are mitigations to stuff like that, right? You can, if a service is not responding and failing, you can retry. Or if some service is completely down, you want to avoid cascading failure, so you introduce circuit breakers to reduce the impact and not affect the entire system. But while we do have a lot of CRUD applications at Wix with a lot of request responses, at the same time, we really rely very heavily on an event-driven architecture as well. So it's kind of a hybrid architecture. And this type of architecture really makes everything a lot more resilient. And I would also say decoupled. So if we have some event happening on the site infrastructure level, right? So all of these verticals are interested in that. So imagine all of them now calling the site infra service and requesting all kinds of information. So that can really get a really big bottleneck and really slow things down. So you can cache a lot of the responses, but caching is a mechanism that's really need to be deployed carefully. You want to avoid stale values because stale values can really corrupt your data and provide incorrect answers. So if you have just events being emitted from the site infra service, so all the verticals, different verticals like e-com and restaurants and hotels can consume them and decide what's interesting to them and keep that smaller data set on their side, you get a much more resilient distributed system here. You get a lot more, like the decoupled nature means that you reduce blast radiuses, you kind of silo issues, right? If the restaurant's consumer of site events has some issue now, it just cannot affect any other vertical. It's impossible, right? So that's a great advantage. And I'm sorry for the long answer, but also Wix, like I said, evolved from only catering to do-it-yourself site owners to actually work with developers. And then they also require to know sometimes what's going on in the site. And one of the ways, like if they develop JavaScript on top of a Wix site, they want to get sometimes JavaScript callbacks and do actions when stuff happens. So naturally, it will be much easier to expose all the rich possibilities that the Wix platform offers as JavaScript events or callbacks than you would want to have the ability to emit events from all of your microservices potentially, right? To make it a platformized effort so that it easily then translated over to this JavaScript callback or to an HTTP webhook and stuff like that. So it gives you flexibility, resilience, and the ability to layer stuff one on top of the other much more easily in a more robust way.
Okay, thank you. So just to kind of recap a little bit of that, right? You're talking about how you've got services and some of them have, let's call it an appetite for eventual consistency. To the point, I guess it's maybe not binary, but they cannot accept eventual consistency, and those are probably going to be more likely to be your CRUD-based endpoints that you were mentioning. And then there's the ones where it's okay, maybe we can accept some eventual consistency, so they may take on a more event-driven pattern. And you also spoke there about cascading failures and the Russian doll of HTTP requests, right? Which is a very difficult problem. I think the paper that I often refer to here is the Twitter paper on Finagle, where they were trying to solve something like this with retry logic, baking it into like a client library, which is now spun out to service mesh. Is that the approach that Wix take? Do you use service mesh to provide that tooling to your application developers, or have you gone down a different route to kind of help them with retries and circuit breakers? Like, I'd really love to understand how you've implemented that.
Sure. So yes, we do utilize a service mesh, and I don't think there's a standard circuit breaker mechanism at Wix, and I think retries at the end of the day the responsibility of the specific service, like as a client. I think service mesh in our case mostly helps with easy like discoverability and easily addressing the correct service and not needing to worry about it the request getting to the correct place. And so in that respect, what we do try to enforce in these requests usually, like the default time that a request has to get a response is quite short. I don't remember the exact amount of seconds, but it's quite short. So you have to have a good reason to then increase it, right? Because the longer the response can potentially be allowed to return, the more problematic it is for the health of the distributed system, right? So the time budgets here are quite constrained, and if a service does not meet up to those standards, then they need to work hard on the performance, right? Improve their RPC endpoint. And if their database is starting to act up, then they need to investigate how to solve it and maybe switch to a different technology and stuff like that. But I would say that for Wix, a lot of the services don't suffer necessarily the scaling issues because of the funnel I talked about. So we have like the heavy duty services that have very specialized data storage solutions, and others usually are quite fine with MySQL. So you will get MySQL in the last few years introduced document database. So because we were heavily invested in MySQL, we took the ability to now work with documents and JSONs with MySQL in both hands, and we have a database layer on top of that. So it's really simple and fast to create new domain entities and to persist them and update them. And in terms of the latencies and performance, usually it works quite well, and they get their own tables. So sorry about the rabbit hole, but maybe I'm my own Russian doll here. But in terms of on getting the best performance and resilience, it's up to the developer at the end of the day. The developer, like if I'm starting to notice that my KPIs are starting to be problematic and it's because of this service, then I may reach out to them and ask them to fix their performance if they haven't noticed it. And another way I can do it is I can consume their events and have my own materialized view, and then just take the responsibility for performance completely for my on my end, which is like you said, if you can do it in eventually consistent way, then it's definitely an option. And I think at Wix, like 99% of the cases, eventually consistent is good enough.
Okay. There was a lot there in that answer. So let's cover a few things and remove a few assumptions for the audience, right?
Yeah, when you interview me, you need to keep a notebook.
I have been taking notes, so you'll have heard my keyboard chatting away. But
yeah,
we both mentioned service mesh. You confirmed there is some service mesh. You're using some API surface of that. So I just want to clarify: does Wix run on top all these 2,500 services on top of Kubernetes?
Yes.
Right. Okay. Cool. You also spoke
short
about
answer.
yeah. Well, we're going to get to the harder stuff, so don't you worry. Plenty of time for us to chat. But you spoke about the application developers and their responsibilities. Where they get to select their own tooling, their own databases. They're responsible for client-side retries and such. You're on the back-end infra team, right? You lead the back-end infra team. So I'd love for us to understand how the responsibilities at Wix work with regards to what does the backend infra team provide? Is it just cluster? Is it SRE semantics? Is it observability? Is it guidance? Are you embedded within application teams? Like, can you go into just how you work with the devs and how you put this all together?
Sure. So there are two levels of infrastructure for backend at Wix. There's the more, I would say, low level part, which says, okay, we're running Kafka. How can we translate that to work well with microservices? Or, okay, we're running MySQL. How can we simplify it for like routing layers on top and make it easier to work with, and also caching and stuff like that. So we have a caching solution that is partially based on AWS DynamoDB, like the second layer. So I would say it's like the more cloud infrastructure translations to microservices level. And then on top of that, we have I would call them the platform engineers, maybe. Their goal is to make like building a microservices super simple and fast. Okay. So the journey for the developer usually starts with writing the interface in protobuf. And it's not only the interface of the service, like what RPC and Kafka endpoints are part of it, but also a lot of the tweaks are done in Proto, and then code is generated behind the scenes for it to work. And then you complete a little bit more configuration in code, and you can focus on the business logic. So because you have database layer that you work with, and I'm talking about like the 80%, right? It's not like each and every service of Wix, especially not the like really high scale ones. They can't operate under these templates, right? But for the 80%, like we have a lot of verticals, a lot of various segments that have a little bit less traffic, and all of these tools and this framework basically really allows them to focus on like the domain challenge, right? How can we make sure that we provide the best booking solution and make it so you can have all these cool features on like sending reminders and is starting soon and be able to easily rebook classes and maybe suggesting classes that are similar, right? So all of these rich business domains, they can focus on that. And what do they get behind the scenes? So they get the auto-generated RPC endpoints. So all they need to do is fill in the what action to take when they get such a request, and how to handle and process an incoming event, right? They need to write that in. And if they need to interact with the database, so usually they just work with our simple DB layer that I mentioned before. It's works with document flavor of MySQL and with JSON support. So what happens? You get your RPC or Kafka domain entity, and you use another tool that you can employ here, which is auto mapping to your data layer entity, right? So, and that data layer entity, you can easily add indexes if needed to get better performance and stuff like that. So the idea is to really abstract away the intricacies of the SQL queries or stuff like that. And you also will get built-in like PII encryption when needed, or the built-in notifications and segmentation needed for GDPR and stuff like that, right? And now we're getting to the data locality realm where, because of other regulations, you need to keep something only in Europe or only in the US and stuff like that. So all of that can be taken care of for you seamlessly. Yeah. So if I recap, we get like the platform engineers giving you really simple interfaces to auto-generate the code, and we're actually really excited about the possibilities of large language models like ChatGPT to harness all the great work that's been done so far and take it to the next level and increase velocity even further.
Okay, awesome. I always like to just give like that 10-second recap to make sure I understand everything and we haven't missed out on any of the good details there. You got like the low-level cloud infrastructure team, the backend infra team, where you're providing the Kubernetes clusters, the cloud resources, and all that stuff, right?
Yeah, so that's another part of Wix. Wix is a big company. So like the cloud infrastructure is run like outside of the backend. And then I'm part of the, you can say cloud infra for the backend. And actually, we developed a lot of cool stuff on top of Kafka, right? Because you want to make sure that you get the best performance out of Kafka possible. And to solve all these tricky edge cases of, oh, wait, for some reason, the service pod wasn't able to reach the Kafka broker for some reason. And we added resiliency layer here. And for the consumer side, we added resiliency because we implemented all kinds of reach-wise strategies built in. It's really easy to configure. And so we have a rich set of like event-driven and messaging infrastructure on top of Kafka. And we also have self-service tools to manage issues in your production environment. So things like easily pinpointing an event that you're interested in our control plane that we built, or investigating why some partitions in Kafka have a consumer lag on them, and saying what events potentially got stuck in the processing, and also be able to skip or replay events. So you can see that it's a bit more like infrastructure and production-y on that level. And the level on top of that is like having the frameworks in place to like write a microservice skeleton in a few minutes and focus on the business logic.
Okay, great overview there. So I think we've covered a lot of like the back end, the platform engineering, providing tooling. We've got the application developers over here. They only really need to focus on their business logic. Especially, and I want to kind of look back into event-driven architectures, right? So we've got all these application developers, and I don't know how many application developers you've got, right? But I'm going to take a guess. You've got 2,500 services. Let's assume any team is responsible for say 10. That's 250 teams. Let's assume 5 persons per team. We're potentially talking about 1,250 developers. Is that anywhere close?
I think it's in the ballpark. Yeah.
Okay, cool. So, that's a lot of people hopefully focusing on our domain logic. But, based on the conversation we've had so far, I'm curious. We've got event-driven systems, which are notoriously hard, right? They've got a service, it's an event, and they decide, oh, I'm going to change the structure of this event. And they're sitting there going, is this an upcast? I create a V2. Is it a new event? Do they get support from like the backend teams, the platform teams, the people with experience? Is there like, are they expected to know all of this, or do you guide them on this? Do you support them through that?
So I think one of the subjects here is schema evolution and versioning, right? So definitely we have like design guidelines and platformization guidelines on how to make sure that when you design your microservice, you write a forward-looking API, but also one that can evolve over time. And also, because of the power of protobuf, you can also easily add linters that make sure that you don't easily mess that up. So and because of auto-generated code, so it's built in with the /v1 for the first thing, so it will be easy to do a v2 and if needed. So we don't really have like automatic linting for the backward forward compatibility of each of the domain entities that we send over the events. But with protobuf, you pretty much know that it will be ill-advised to just go and delete a field. It's better to like mark it as deprecated and add another field. So there are definitely guidelines on how to do these minor changes to your schema. And I think, I don't remember, there are some basic rules that enforce some stuff. So, but I can't recollect them right now. So some of this is responsibility of the developer, But because like part of the onboarding process of Wix is how do you write a product which is API first, right? It used to be different. It used to be like, okay, so we have some UI and some backend service behind it, and so the UI is going to ask all kinds of things. So we need to build an API for it. But because we've evolved Wix into a platform that also has developers on top of it, and because it's a bigger company now, so you need developers to communicate. You don't want like Slack or Microsoft Teams to be a barrier to understand how to consume something from some event from another service, right? So we want everything to be well documented, easily discoverable, and easily evolved, right? So I can safely stay on the older version for a while, especially if I'm an external developer, right? And then safely migrate on my own time to the new version. And it will be the responsibility of the service owner to make sure that both versions are supported.
Okay. And are you leveraging, like, just because you mentioned kind of discoverability there, right? Are you leveraging anything like Backstage, like an IDP that aggregates and collects all of these service definitions and the event definitions and the protobuffs and gives someone a place to go and search them?
Sure. So actually, because of like the unique nature of Wix's platform, a lot of work has been done to expose things to external developers, and we built it by ourselves. So there was no point in like not doing the same for internal developers. So there are products out there, right? For instance, especially for events, we have the Confluent Schema registry, and there's also API Curio, I think, or something like that, from Red Hat, like open source. And those are great tools for managing and discovering event schemas. Specifically for Wix, we built our own custom services. So each time a new service is written, its protobuf has the event definitions. They are transferred automatically to the main repository that keeps all of the definitions, and you can also listen if you're like a CI/CD service or some other build related service that cares when new events are created, so that you can do stuff with them. You can listen to that and create all kinds of cool stuff on top of that. And also, I think for RPC communication with the service mesh, it's also important to know that a new service has been created or updated, and so events are emitted on that as well to allow the communication to be simple there as well. And so because of everything is based on protobuf, you get the schema, you get well documented stuff, and once you translate it hopefully to a strongly typed language like Scala or TypeScript, you also get type safety when you consume it and or call the RPC endpoint as well.
Awesome. Let's kind of jump back to something you said earlier as well. So I love that answer, right? You're saying that you're a developer company, you've got public facing APIs, there's a bit of dog fooding, the discoverability is the same as the people that use the platform, which is awesome. That's kind of what I took away from that. So I hope that's correct. But you also said earlier that, sometimes you have to approach an application team because they may not have noticed that the round trip time on an API request is like, it's growing exponentially, it's getting out of control, whatever that regression is, could be anything, right? I'm assuming they maybe don't know a lot of the times that they have dashboards, metrics, traces, logging. I'm assuming these are potentially provided by like the templates you mentioned, which are provided by the platform team. So they're just taking this cookie cutter boilerplate and injecting their domain logic, maybe not aware of all the stuff that's going on in the background for them. It got me kind of thinking, like, is Wix a polyglot organization? If I was new at Wix and I've got a service that I want to write and there's no template for like Rust or Elixir or Ponylang, and I'm like, hey, I really want to do this in Pony. Are you going to just tell me no? Or is there a process there to bring on like new technologies?
Sure. So every technological stack has a new one, has incurred like cost in an organization. Especially for like you have one developer that's super excited about Elixir, and then writes a service in Elixir. But what happens when they decide to leave the company? Like, who is going to maintain this Elixir service? So we started off on the JVM, mostly Scala, and then it was apparent that because there are a lot of front-end developers writing JavaScript, and you want them to easily write middleware services and rendering services. So relatively quickly, like Node.js became an additional first-class citizen, like with Scala. And in recent years, they are starting to gain like a bigger effort to expand like the offering. So why not write in Java and Go and Python as well? Now, in order to achieve that, like I mentioned, a very complex, let's call it platform framework and a lot of stuff. So it's not, and that's on the JVM, and it's not really so simple to achieve that. So one way that we're experimenting now is with kind of a sidecar pattern with two containers, where we have the host container, which is running the JVM and all of the cool microservice infrastructure that I talked about. Then you have the guest container that can be a Node.js container or a Python or a Go container, and they communicate via gRPC. And just so you specify the proto, because proto can be in any language, and you can implement your event handler or your RPC endpoint in the languages I mentioned, and it will get invoked from the host that will actually do the heavy lifting. Another approach we're contemplating perhaps is utilizing GraalVM also to get that working. But like in terms of cost benefit analysis, I think definitely I don't see like the engineering of Wix going to, hey, just write in any code like language you ever saw, and because it's cool. Because at the end of the day, there's this production system that needs to be well maintained and get good performance and keep our customers happy at the end of the day.
Awesome, thank you. Okay, so based on everything you've just said, there's a lot of JVM happening, and you mentioned Graal as well, right? But they're definitely heavy JVM users. Your event-driven architecture on AWS, you've got Kafka in the mix, which is notoriously difficult to kind of scale. It was resource intensive. The costs must be rather astronomical, I would imagine, for a company of Wix scale. You mentioned that wonderful number at the start of the episode, 70 billion, I think it was, events per day. So maybe you can dive into that a little bit more detail and tell us what's interesting from your perspective.
Sure, I would love to do that. So basically, over the last couple of years, we're trying hard to see how we can keep the costs down. So I mentioned that new microservices spin up every week, but we need to see how the infrastructure costs don't increase linearly with that, right? So we have our infrastructure on top of Kafka, for instance, and we saw that we need to have a lot more Kafka brokers, because we have so many microservices and all of them need to connect to the Kafka brokers and understand, like, is there something for me to consume now, right? Now, not all pods of all services are going to get stuff they need to consume, but they're going to run our infrastructure and waste CPU and memory in order to do that. So in order to mitigate this, we actually created 3 services for each of the basic Kafka features. So you have a Kafka producer, a Kafka consumer, and a Kafka administrator. So for each of them, we created a proxy that in this way we can really, really limit the amount of connections that we need for the brokers. And then we can really limit the amount of brokers that we actually need to run. So while the admin proxy and producer proxy is really kind of straightforward to do because they're stateless, for the consumer proxy, it's been a real adventure where you need to keep like the state of which consumers are now connected, and to shard the and load balance between the pods, and have a lot of work on like the stateful nature of consuming from Kafka, which is really exciting and challenging. And we're also trying to reduce Kafka-based traffic because that's also quite expensive for us. So we're considering, now that we have our service, our proxy service, we're considering doing all kinds of events caching and stuff like that in order to, if you have a lot of consumers for the same event, we can reduce the pressure on Kafka and just sometimes get caches from ourselves, so from our proxy service. So a lot of really challenging technical stuff we're doing now in order to reduce our Kafka bills, basically.
Wow. Okay. So the problem statement there, right, is you have so many consumers and producers of Kafka connecting to all of the Kafka brokers that you're having to scale out horizontally the brokers to handle the amount of connections. So in order to avoid that, that's a cost sink, right? We running a JVM on a container on top of a Kubernetes cluster is quite a chunky thing to do, and then you've got that across so many services. Yeah, okay, I understand the problem statement really well. You've went on the solutions approach of, you said you wrote 3 proxies, right? But it sounds like they're slightly more sophisticated than just a proxy. Like they're actually their own little orchestrator within the cluster. So all the consumers and producers, sorry, I'm cutting you off here, but all the producers, the consumers only ever speak to your proxy, and then it handles some, I guess, like delegation of all the Kafka workloads.
Yeah, so when you have a lot less producers connecting to actual Kafka producers connecting to the Kafka workers, that like you don't need the 2,500 services times the number of pods they have to connect. You need a much smaller set of producers to actually do the work for them, and then you really limit the amount of connection. That's how you save producer connection. And over on the consumer side, so yeah, you consume for them, and then you delegate to them via RPC, which is much less cost intensive in our data centers. I hope that clarified it.
It does, yeah. It's really interesting. Just fun problems and fun solutions that you get to work on. And really, I think it's just exciting that you're able to kind of share that with the audience. I think they're going to take a lot away from that. So thank you for sharing that with us.
Yeah, I enjoy coming to work every day.
Awesome. We have gone over time, so thank you for being patient and answering all these questions. I could easily talk to you for another hour. I think we'll maybe do a part 2 in a little while if you're up for it. But let's finish with something a bit more fun, just to kind of get us on the way. But you've mentioned a lot of tools in today's episode, right? From Kubernetes to Kafka to MySQL to the Scala to Graal. Like, if there were only 3 tools that you could pick and everything else would just be removed from you, like, what are the 3 most important tools to you in Wix Engineering that you just could not live without?
For myself or for Wix Engineering?
Let's do both. Let's start with you.
Okay. For myself, I actually really enjoy working with the functional library on top of Scala called Zio, which I really enjoy working in every day because it's really tuned for high concurrency and asynchronous work, and get all the benefits of functional programming. So I really enjoy working it every day. Don't take it away from me. And I think Kafka has proven to be very powerful and versatile, and so we solve so much with it in Wix. So I definitely don't see like Wix without it. That's like the 2 biggest ones for me.
All right, awesome. Okay. And do you want to add any more tools, or do you want to leave it at those? Zio and Kafka, right?
I think those are the ones. Like if you're on the JVM or like not satisfied with the concurrency and asynchronous features from your language, I definitely recommend to check out ZIO library on top of Scala.
Awesome. Thank you. All right. Well, thank you so much for spending time with me today, answering all these questions, sharing all of your knowledge and all the interesting problems that you have in Wix Engineering, and most importantly, how you're navigating and solving them. And I'll give you just a moment. Feel free to share and shamelessly plug Wix, yourself, your blog, your Twitter, if you have a dairy farm, like anything you wish, please feel free to share.
Well, first of all, it was really a pleasure being on the show, and you're a great host, and I really enjoyed your questions and kept me on my toes. And a lot of things I talked about today are on my website, so at natansil.com. Blog posts on ranging from like event-driven architecture and more like Kafka specific. Talked about schema management, and but I also have other software engineering in broader terms related stuff there. And and also I do a lot of talks and a lot of conferences, so you can check out all that at my website as well. And yeah, you can find me on Twitter and LinkedIn for sure, where I get updates on everything that we do at Wix Engineering, which is interesting. So that's it.
All right. Well, thank you again. I will ensure that all of those links are in the show notes for people to check out. So to everyone listening, thank you very much, and we'll see you all next time. Have a great day.